Okay, ladies and gentlemen, so let's learn about scale today. Scale is what people who make maps use to take an object that's really, really big, like the world, and shrink it down proportionally to your phone, where you look at it on an app like Google Maps or Safari Maps, I don't know what it's called, on an iPhone or something like that. So you're taking this massive shape, you're taking the entire world and you're condensing it, you're shrinking it down proportionally to a smaller shape, to a smaller screen, if you will, your phone. Or it can work the other way, where you take something that's really small and you make it really big, as long as it stays proportional, okay? So, to learn about scale, basically what we're going to focus on today is called a scale factor. Now, a scale factor is basically, misspelled that. A scale factor is the rate of change from one similar shape to another. Okay? And I'm going to give you 4 simple, quick examples. Here, in the first one, let's say that I have a box, yeah? And I'm telling you this side of the box is worth 4. And I'm telling you here I have a bigger box. These two shapes are similar, and I have a scale factor of 5. If the left-hand side of my box for the small box is 4, what's the left-hand side of my box for the big box? If I have a scale factor of 5, all I have to do is take that 4, multiply it times my scale factor of 5, and it's going to give me 20. My x is going to be 20. Basically, the scale factor is what you increase by. Let me show you another example. Let's say here I have a triangle. This is worth 3, and I want to find out on a much bigger triangle what the corresponding side on that will be. Now for this one, I'm going to tell you you have a scale factor of 7, right? Well, the scale factor is what you're multiplying by. So to get from the small to the big, you are multiplying the small side length by 7. So you're just going to take that 3 times 7 equals 21. So voila, your x is going to be 21. Your scale factor is your rate of change. It's how much you're increasing by in this particular case. I know I said I'd give you 4 examples, but let me just give you 3. I don't really think the point has to be belabored too much. Okay, so here, what about a rectangle? Now, let's draw the other way. Let's say I have a rectangle here and a rectangle here. Let's say I tell you the bottom of this rectangle is 20 and the scale factor is going to be 3. What's the value of x down here? Please notice that I'm always comparing corresponding sides. Like if the value of the small rectangle on the bottom is 20, I'm interested in finding the corresponding value for the bigger rectangle, again, on the bottom for x, okay? Now the scale factor is telling me that I increased from my small figure to my big figure by a measure of 3. So 20 times 3 is going to be 60. X equals 60. That's how you use scale factor to find the measurement of corresponding shapes. I'm sorry, the side lengths of corresponding shapes.